Diddy the magic monk. Diddy the magic monk. Diddy the magic monk. Diddy the magic monk.
Hey guys, welcome to another integration using partial fractions tutorial. This is probably going to be the last one because I think we would have covered everything you need to know. The rest is just going to be a lot of practice. Now, this question is not an easy question. Okay, if you haven't done all my other tutorials, if you haven't done a lot of practice on all these questions, you probably shouldn't attempt this. And even after you've done all that, when you attempt this, you might find it really difficult, but don't feel bad. My guess is if this question appears on the test, it's going to be one of the harder ones. It's probably going to not appear on the test because it takes a really long time. But, you know, it's probably better to be prepared than to be sorry. So we're going to go through this. Just be prepared. It's not a quick journey. So the first thing we realize is this term here, x squared minus 1. X squared minus 1 can be simplified into x plus 1, x minus 1. Okay, using one of the expanding factorizing formulas, difference of 2 squares, something like that. So we're going to do that first. So then that becomes x plus 1, x minus 1 over here. Okay, so that becomes this. All right, probably could have written that a bit better. But then, to simplify that further, I have x plus 1 to the power of 3 times x plus 1. So I'm going to change that to x plus 1 to the power of 4, x minus 1. So that bit here, I've just made it to the power of 4 because it's to the power of 3 times by itself again, so it's to the power of 4. Okay, but how would I even split this up? Now let's talk about it. Now, here is a general formula you have to remember. When you have a fraction, it doesn't matter what it is at the top, over x plus something to the power of something. Okay, and you want to split this up into several fractions. You want to split it up into several fractions. Then on the bottom, whatever n is, you would have to go x plus box to the power of 1 plus x plus box to the power of 2 plus x plus whatever it is to the power of 3 all the way to x plus something to the power of n. Right, that's the general formula for breaking it up. It's just how partial fraction works. So what that means is I'm going to have to break this up. And then initially I would just have x plus 1. But then I would have x plus 1 to the power of 2. Now notice it goes up to 4. So I need to go all the way up to 3, 4. Okay, and the last one is x minus 1. So I have A, B, C, D, E. I got 5 constants I'm trying to find. Okay, how would I even find it? There's so many. Okay, it's not easy to do. That's why I said it's a hard problem. So then what you want to do, okay, to try and get what A, B, C, D, E is I'm going to now try and combine these 5 things together. Okay, so then you would combine them by going, okay, the bottom is obviously going to become this. Now, what would I need to do to a? Okay, if I want to turn the bottom fraction into this, I would multiply a by x plus 1 to the power of, it's already got a 1 here, so to make it to the power of 4, I need to raise it to the power of 3, and then I also need to multiply by x minus 1. Okay, and then I'm going to go plus b. It's already got x plus 1 to the power of 2 here, so to make the bottom of the fraction x plus 1 to the power of 4, I need to multiply it by x plus 1 to the power of 2, x minus 1. Okay, it's basically about, if I want to make the bottom of the fraction into this, what do I need to do to the top? So c would be x plus 1, x minus 1. Okay, already you can see this is going to turn into a bit of a headache. D is going to be x minus 1, just x minus 1, and e is going to be x plus 1 to the power of 4. Okay, so that is how you would do that part. And now we're going to make the top equal to the top of the other side, the top of the other fraction. So the top of all of this, all of that stuff is going to equal 8. Right, so that bit is pretty similar to what we did before. So 8 equals a bracket x plus 1 cubed x minus 1 plus b bracket x plus 1 squared x minus 1 plus c bracket x plus 1 x minus 1 plus d bracket x minus 1 plus e bracket x plus 1 to the power of 4. Barely fits on my screen. How crazy is that? Okay, so now, in order for us to continue, we're going to think of some very simple numbers. Okay, let x be 1. Why would I do that? Because when x is 1, if I substitute that into all of the places where x is, I put 1 inside every time x appears, then 1 minus 1 is 0. So any term with x minus 1 turns into 0. So that bit will turn into 0. This 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 bit will turn into 0. So then you only have e times x. Well, it's just x is 1. So it's 1 plus 1 to the power of 4. And then you have 8 here. So 8 equals e times 2 to the power of 4. So 8 equals 16e. E equals 8 divided by 16, which equals half. E is a half. Okay, so we found one of them. That's easy to find. Okay, let x equals -1 now. That should help us find something else. So when x is -1, right, anything with x plus 1 in it is now 0. Right, because -1 plus 1 is 0. So anything with x plus 1 is gone. So that means I have 8 equals d x minus 1. Okay, and then if I try and solve that, -1 minus 1 is 8 equals d times -1 minus 1 is -2. So d equals 8 divided by -2. D equals -4. So I found 2 of them, D and E. D and E have been found. D is -4. E is half. Okay, so that's not too hard. Now we're just going to have to find A, B, and C. Now, there is no easy way, unfortunately. I've thought about it for a long time. Maybe if you can figure out an easier way, you can tell me what it is. But I'm just going to think of other numbers for x that's going to help me simplify it. Okay, so I'm going to think of another number for x. Let x equal 0. Okay, because you can let x be whatever you want as long as it helps you simplify this. Right, so if x is equal to 0, all right, then I would have 8 equals 0 plus 1 is 1. 0 minus 1 is negative 1. And then I would have a at the front or at the back, doesn't matter. So it's basically 0 plus 1 is 1. 1 cubed is still 1. 1 times negative 1 is negative 1. So it's negative 1a. Okay, and let's keep going. So I have 0. So I got plus b. And then I have 0 plus 1 is 1 squared. And then I have 0 minus 1 is negative 1. So it's negative 1b. And then I have c. So I got 1 times negative 1. So it's negative 1c again. And then I got d. So that's minus d. Because 0 minus 1 is negative 1. And then I got e. So e is 1 to the power of 4. Okay, so now d and e, we already know what it is. So that's going to help us a little bit. D is negative 4, so plus d is plus 4. And e is half. Okay, so I'm just going to move this to the left. Move it to the left. So it'll be 8 minus 4 minus a half is negative a, negative b, negative c. Okay, so 8 minus 4 is 4. 4 minus a half is 3.5. 3.5 equals negative a, negative b, negative c. Okay, so we're now going to continue find some other simultaneous equations because we have 3 unknown variables, so we'll need 3 equations to help us solve it. So I'm just going to copy this, might not even fit, copy this. So we're now going to let x, we have already tried, x is 0, negative 1, 1, so now the only thing to try is I guess 2 and negative 2. Okay, so let x equal 2. Okay, we're going to put 2 inside wherever x occurs. So then we have a, we have 2 plus 1 is 3, so that's 3 cubed. 2 minus 1 is 1. And then I have b times, again, 3 squared. Times 1 again, because 2 minus 1 is 1. So wherever you got x minus 1, that's going to give you 2 minus 1, which is 1. So then I have c 3 plus d plus e 3. 2 plus 1 is 3 to the power of 4. Okay, so then we're going to keep going. So then we got 3 times 3 times 3 is 27a plus 9b plus 3c plus d is negative 4 plus e. Now 3 to the power of 4 is 3 times 3 times 3 times 3 plus 81. Now e is a half, so it's 81 times a half, whatever that is, 40.5. Okay, so now I'm going to go 8 plus 4 minus 81 times a half is 40.5, so minus 40.5 equals 27a plus 9b plus 3c. Okay, so 12 minus 40.5 is negative 28.5. Negative 28.5 is 27a plus 9b plus 3c. So then we're going to divide everything by 3. Divide everything by 3. So we will get 9a plus 3b plus c. And this will be negative 9.5 after you divide everything by 3. Both sides. Okay, so that's our second equation. We need 3 equations, okay, because we have 3 unknown variables. So we got 1 equation, 2 equations. Now let's try a third one. Let x equal something else. Okay, so just to make it, there is no quick way. We're just going to have to do all this again. So let's copy this. Let x equal. So what have we tried already? We've tried x equals 2, x equals 1, negative 1, 0, 2, negative 2. Let x equal negative 2. Okay, so we put negative 2 wherever x is. So then that'll give us 8 equals a times negative 2 plus 1 is negative 1. So wherever you have x plus 1, change it to negative 1. So I'm just going to do that to make it slightly quicker. X plus 1 is negative 1. And then wherever you have x minus 1, negative 2 minus 1 is negative 3. Okay. X minus 1, negative 2 minus 1 is negative 3. So that should say negative 3 here. Okay, so now we are going to continue with that. So negative 1 to the power of 3. Anytime you have negative 1 to the power of an odd number, it's going to be negative again. So that's just negative 1 again. So a negative 1 times negative 3 is positive 3. Okay, b negative 1 squared is positive 1. Positive 1 minus 3 times minus 3 is negative 3. C is positive again. Negative 1 times negative 3 is positive 3. Minus 3d plus negative 1 to the power of 4 is 1e. Okay, 8 equals that. Okay, so now, how would we simplify this? 3d equals, if we can even remember what d was negative 4. So d is negative 4. And e is half. Okay, so if we keep going with that, 3a minus 3b plus 3c. So that becomes 12. So, and this becomes, this is just a half. So 3a minus 3b plus 3c equals 8 minus 12 minus a half. 8 minus 12 minus a half is negative 4.5. And that is our third equation. That is our third equation. So we have three equations we want to solve. And I'm just going to write the three equations together. Okay, let's just do it here. The three equations we want to solve. So these are the three equations we're trying to solve. Okay, now in an exam situation, for you to figure this out, I would suggest that you use a graphics calculator and just type it in. So if you have a graphics calculator like this one, okay, what you would do is you go to second matrix, and then you're going to go to edit the first matrix, which is A, and it's a 3 by 3 matrix. And you're just going to type A, B, and C, A, B, and C, A, B, and C, the numbers in front. So I have -1, I have -1, I have -1. Okay, the numbers in front. So we got 9, 3, 1, and I have 3, -3, 3. Okay, so the first matrix is going to have the numbers in front of the coefficients. Get out of that. The second matrix, matrix B, is going to have these three numbers. So it's a 1 by 3 matrix. Oops, 3 by 1 matrix, sorry. 3 by 1 matrix. And it's going to have these three numbers. 3.5, -9.5, -4.5. Okay, and then I'll get out of that. And then all you need to do is you're going to go to matrix again. And it's the first matrix, the 3 by 3 matrix. The inverse of that matrix, times by the second matrix, which is your solutions. Okay, press enter, and these are your answers. So going down the list, you have A, B, and C. So A is 0.5 negative, B is -1, and C is -2. Okay, so using these answers, A is -0.5, B is -1, C is -2. Okay, now we're ready to integrate. So in order to integrate this, I'm now going to break this down into 5 integrals. I have the first one is -0.5 over x plus 1 to the power of 1 plus -1 over x plus 1 to the power of 2 plus -2 x plus 1 to the power of 3. Okay, and then I'm just going to keep going, plus -4 over x plus 1 to the power of 4 plus half over x minus 1. Okay, so let's now do these one by one. Might copy them to where there's a bit more space. Okay, so let's now try and do this. Equals. Now the first one should just be a straight ln. ln x plus 1. Okay, when you differentiate ln, basically whatever we write here should differentiate into what we have here. So when you just write ln, that's going to give you 1 over x plus 1. But because we have a negative 0.5, I'm going to add that at the front. Okay, so now to integrate this one, what we need to do is we need to firstly show you how to differentiate into this. So we want y dash to give you x plus 1 at the bottom, so it's to the power of negative 2 times by negative 1 at the front. That's what we want y dash to be. So y has to be something, so y dash is equal to this. Now, if I had x plus 1 to the power of negative 1, that means when I differentiate it, I will move negative 1 to the front, which is what is over here, and change this to negative 2. So it matches already. So the answer here is going to be x plus 1 to the power of negative 1. That will differentiate into this. And then here again, I have x plus 1 to the power of negative 2 because that will differentiate into this. I'll just show you y equals x plus 1 to the power of negative 2. Y dash equals negative 2 x to the power of x plus 1 to the power of negative 2 minus 1 is negative 3. So that matches this. So that matches this. So then this will be x plus 1 to the power of negative 3. Actually, that bit won't match. So I need to try and y equals x plus 1 to the power of negative 3. Y dash equals negative 3 to the x plus 1 to the power of negative 4. So that's negative 3 over x plus 1 to the power of 4. So that's negative 4 here, not negative 3. So I need to somehow change negative 3 to negative 4, and I can do that by dividing by negative 3 and multiplying it by 4. Okay. Dividing it by 3 times by 4, sorry. And that'll give me negative 4. Okay, so then I'm going to continue. And the last one here, again, is just a straight ln. ln x minus 1. ln x minus 1, now there's a half at the front, so then I have to add a half at the front. And then plus c on the end. So to clean that up a bit, it's negative 0.5 or negative a half, because people don't like decimals. So I have negative half ln x plus 1 plus 1 over x plus 1 plus 1 over x plus 1 squared plus 4 over 3 x plus 1 cubed plus half ln, oops, too many straight lines, ln x minus 1 plus c. Okay, that is your final antiderivative. Now guys, even though this is definitely the answer, there might be some teachers or some textbooks that insist that you simplify it and they give you the answer in simplified form. So we might as well show you how to simplify it so that it matches your textbook answer. So to simplify it, let's put all the terms with x plus 1 or something like that in the numerator together for 3x plus 1 to the power of 3. And then let's put all the ln together. There's a minus half ln plus c. So I'm just rearranging it. Okay, so now the first bit, we're going to combine these three fractions into one fraction. So we're going to make the denominator the same, which is going to be 3x plus 1 cubed. So in order to turn this fraction into the same denominator, I have to multiply the top by, it's 1. So 1 times, it's a 3x plus 1 squared. Why is it squared? Because it's already got x plus 1. So to turn it into 3x plus 1 cubed, I need to multiply it by x plus 1 squared. Plus, and then this one already has a squared, so I just need to multiply by 3x plus 1. And then the last fraction, I don't have to do anything because it's already got 3x plus 1 to the power of 3 on the bottom, so I just put a 4 there. Now, I'm just going to do this first part, finish it off. So I'm going to expand all that out, so that becomes 3 times x squared plus 2x plus 1. That's what x plus 1 squared gives you. X squared plus 2x plus 1. Plus 3x plus 3 plus 4 over 3x plus 1 cubed. And if I keep going with that, 3x squared plus 6x plus 3 plus 3x plus 3 plus 4 over 3x plus 1 cubed. And if I keep going with that, I will get 3x squared plus 6 plus 3 is 9x plus 3 plus 3 is 6. 6 plus 4 is 10 over 3x plus 1 cubed. Okay, now let's work on the right hand side. So, sorry, work on these two. So then I've got a half, which I'm going to take it out. So it's half ln x minus 1 minus ln x minus 1 plus c. No room to write the plus c. And then, if you guys remember a log rule, okay, log a minus log b equals log a over b. So putting that inside here, I will then get half ln x minus 1, so that's the first one, over x minus 1. Okay, did I copy something wrong? Yes. That's meant to be a plus. Okay, that's meant to be a plus here. Okay, so then you just keep copying all that down, blah, 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 keep copying it down. So the final answer is half ln x minus 1 over x plus 1 plus c. Okay, thanks for watching, guys. See you next time.